Here's section P3, and in section P3 we'll be talking about radicals and rational exponents. The first thing we have to have a firm grip on are the vocabulary words that we'll be using. So this entire problem is a radical, and here are the different parts. First of all, the number that is underneath the radical sign, which is what that's called, that's a radical sign. We have the radicand. The radicand is the number underneath the radical sign. And then, of course, up at the top, we have the index of the radical. Critical terms that you need to know because I'll use them over and over as we go through this section, and also over and over as we get into trigonometry later in the year. So the radicand, the index, the radical sign. So basically, this is asking a question. So we have the square root of 64. Obviously, the square root of 64 is 8. But this problem is asking the question, what one number times itself twice is 64? And this is the essential question here for this particular section, understanding the actual question that's being asked when we look at a radical. Now, things to remember. The radical sign is a grouping symbol. It is a grouping symbol, which means that we've got to apply order of operations. I mean, we're not ever not going to apply order of operations. It's always in effect. So here we're going to do some evaluations, and the first thing to point out is in number 2 we have an index of 3. Now just a reminder, if you do not see an index on a radical, then it is understood to be a 2. With an index of 2 we have a square root, and an index of 3, we have a cube root. When we have an index of 4, a fourth root, 5, a fifth root, and so on. So we're going to evaluate here. Remember also that evaluate means essentially the same thing as simplify. We're not solving anything yet. We'll be solving a little bit later in this chapter, just evaluating here. So the question that number 1 is asking is what one number times itself is 81, and that of course is 9. 9 times 9 is 81, therefore the square root of 81 is 9. Number 2, what number times itself 3 times? We have an index of 3 here, so it's asking a different question. What number times itself 3 times is negative 27? So one thing we can do here, if you don't know off the top of your head, is think about negative 27 in terms of negative 1 times 27. And while we cannot get a real number for a square root of a negative number, we will get a real number when we take the cube root of a negative number. Why? Because negative 1 times negative 1 times negative 1 is negative 1. So we will get a real number when we take the cube root of a negative. So the cube root of negative 1 is 1, and the cube root of 27, for 27, we can quickly make a factor tree. It's 9 times 3, which is 3 times 3 times 3. So the 27 can be replaced with 3 to the third, and the cube root of 3 to the third is 3. So negative 1 times 3 is negative 3. So the cube root of negative 27 is negative 3. So numbers 3 and 4 at the bottom are good examples to remind you once again that GEMS, or order of operations, is always in effect. So if the radical sign is a grouping symbol, then we need to look inside the grouping symbol first and simplify according to order of operations. So we've got a square root here, an index of 2, and underneath that radical we have 6 squared, which is 36, and 8 squared, which is 64. Now, since it's all underneath the radical, we need to perform the addition first. So we're having to simplify as much as possible within the grouping symbols. And of course, 36 plus 64 is 100. So what we're actually after here is the square root of 100. What number times itself equals 100? That's 10. Now let's compare that to number 4, which is the square root of 36 plus the square root of 64. This time, the plus is not underneath the grouping symbol. So we need to evaluate the radicals first because they're a grouping symbol and then add. So the square root of 36 is 6. The square root of 64 is 8. Now we're going to add and we will get 14. Note the difference in the final simplifications of 3 and 4. We're continuing with evaluations here, and these are all square roots. They all have an index of 2. We just don't have to write it anymore. And we see some of the properties of radicals start working here. So first thing to show you in number 1 is that if we have the square root of a fraction, we can turn that into a fraction of square roots. So the square root of 4 is 2, the square root of 9 is 3, so the square root of 4/9 is 2/3. We're only considering principal positive roots here because we're not solving, we're just evaluating. Number 2, if you would like, you can separate this into the square root of 100 times the square root of a to the 6th. And I'm continuing to write the 2's up there to remind you that the index is 2. So the square root of 100 is 10. Why? Because what number times itself is 100? That's 10. Now, let's look at the variable expression. And honestly, the variables are the easiest parts of radicals because if we understand that a radical is a very specialized form of division, all we have to do are divide the exponents. That's it. The base remains the same. So from here, 2 goes into 6, 3 whole times, none remaining. And we can give ourselves a quick check here by looking at 10a cubed times 10a cubed. Do we get 100a to the 6th? Yes, 10 times 10 is 100, and a to the 3rd times a to the 3rd is a to the 6th. So this is our square root. We're going to do it again with the square root of 500m to the 5th. This one's going to take a little more muscle. So first of all, let's separate this and let's think about it. We've got 500 times the square root of m to the 5th. I'll go ahead and make that its own radical there. So let's make a factor tree for 500. 500 is 5 times 100. 100 is 10 times 10. 2 times 5, 2 times 5. Now what I'm going to do is we are going to replace this 500 with its prime power factorization. Prime power factorization. So what does that mean? Well, that means this. We've got 2 powers of 2 times 3 powers of 5. So 500 is the same as 2 squared times 5 to the 3rd. We're replacing 500 with its prime power factorization. So we've got 2 squared times 5 to the 3rd, and we've also got, I'm just going to put it back underneath, m to the 5th. So once again, when it's time to simplify this radical, all we're going to be comparing now are the exponents. All we've got to do are divide those exponents. So here goes. 2 goes into 2 one whole time. Notice the base stays the same. 2 goes into 3 1 whole time, but there's going to be 1 power of 5 remaining. If you look at 3 divided by 2, which is what we're asking, that's going to be 1 and 1/2. Better yet, let's look at it from an improper fraction to a mixed number. The 1 whole comes out, but the 1 remaining is going to stay under. Let's do the 5. So 5 over 2. So 2 goes into 5 2 whole times with 1 remaining. So 2 into 5. 2 powers of m are coming out, and 1 power of m is going to remain. So this is the easiest way to simplify larger radicals with any index and any sort of prime power factorization that you get. So now let's just put everything back together. 2 times 5 is 10. 10m squared, and underneath the radical is 5m. So we're going to use that same process for a much larger radical now. The cube root of 800, a to the third, b to the seventh, c to the 10. So the first thing we're going to do is make a prime factorization for 800. Remember, we're after only prime factors. So for 800, what do we have? We've got 1, 2, 3, 4, 5. 5 powers of 2. So I'm replacing 800 with 2 to the 5th. Notice our index is 3 this time. This is a cube root, not a square root. And then we've also got 2 powers of 5. 3 powers of A, 7 powers of B, 10 powers of C. So let's quickly plow through this. Remember, all we're now going to compare are the exponents. The bases are not changing. 3 goes into 5 1 whole time, but with 2 powers remaining. 3 goes into 2. Will 3 go into 2? No. That's why the 2 powers of 5 are going to remain underneath. Now to the A. 3 goes into 3, 1 whole time. Base is not changing. 3 goes into 7, 2 whole times with 1 power of B remaining. 3 goes into 10, 3 times with 1 power remaining. So there you go. There is your radical simplified. Now we just need to clean this up. So 2ab squared c cubed, cube root. 2 squared is 4. 5 squared is 25. So 4 times 25, it leaves 100 underneath a cube root, and then bc. So that is the quick, simple way to simplify any radical.